Hi, this is Miss Wade again. This is Algebra 2, and this is for section 8.1.3. This presentation is to complement what you learned in 8.1.3 Desmos activity. If you have not yet done the Desmos activity, please log into student.desmos.com, use the code AZ26BM, and work on the activity first. Our goal in this activity is to write the equations of polynomial graphs. So one thing we need to know is what the roots of the graph are. That's where it crosses the x-axis. So you can see the roots in this graph are -3, 0, 0, 0, and 2, 0. This graph has a positive orientation because as x gets larger, the graph is y is getting more positive. It is a third-degree polynomial because it has 3 roots. The equation for the graph then is y equals, and then the quantity x plus 3, quantity x, and quantity x minus 2. We got each one of these factors from the roots, and so that we've written the factored form of the graph. If we look at this graph, we can see that it only has 2 roots. They are -2, 0, and 1, 0. And then we could write the equation y equals x plus 2 times the quantity x minus 1. We get that from the roots, but notice that at -2, the graph doesn't go through the x-axis, but it bounces off of the x-axis. To get the graph to bounce off the x-axis, then we need to square the factor that causes that from that root. Even though this graph has only 2 roots, we can see it's a degree 3 polynomial because as x is small, the y values are negative, and then as x gets large, the y values are positive, making it an odd degree graph. And then you can see then that x plus 2 then is called a double root since it's squared. So that gives us x cubed, or a third degree polynomial. This graph represents a real challenge. We see that it has 3 roots, but we have this funny curve at 0, 0. So the 3 roots are -2, 0, 0, 0, and 2, 0. This would give us the equation y equals x plus 2, quantity x plus 2 times x times quantity x minus 2. But then how do we get that blip or curve in there at 0, 0? If we square x, then that would give us a bounce off of that, but this doesn't really bounce. So we're going to cube x. So we end up with y equals x cubed times the quantity x plus 2 times the quantity x minus 2. The last thing we really need to think about in writing equations of polynomial graphs is what's called the stretch factor, or also multiplier. So you can see in these 2 functions that only difference between the 2 functions is the second one is being multiplied by 3. This means for any x value that we put in either of the 2 functions, in the second one the y value will be 3 times larger. So it'll be stretched on the y-axis. We can see that clearly in this graph. If you look at this set of graphs, the blue graph has a multiplier of 1, and the red graph then we multiplied by 3, has a stretch factor of 3, and you can see that the y values have been stretched, or it's vertically stretched. In the green graph then we our multiplier or stretch factor is 1/10, or a fraction, and you can see it kind of squashes or squishes that graph, and the y values are compressed. If you were to continue to change the multiplier and look at the graphs, you would notice that as the multiplier is greater than 1, as it gets larger, then that just stretches the graph out. And when the multiplier is between 0 and 1, then it compresses the graph. So now the question is, what do you think would happen if the multiplier is 0 or negative? In this graph, we can see what happens when we multiply by a -1. The blue graph has a multiplier of 1, and the red graph has a multiplier of -1, and you can see that it just flips the graph over. So what was used to be going in a positive direction is now traveling in a negative direction, and vice versa. If we multiply by 0, then our y would always equal to 0, and there would be no curve. So this is just to help you to check your answers to slide number 8 in the Desmos activity. It asks you to write the equation of this graph, and it asks about the roots, and so you can read through this as you look at your slide 8 if you would like, and check your solutions and how you got the equation. So for the next slide, then, when Melvin put in we have the equation. When Melvin put in the equation, y equals x plus 3 times the quantity x plus 1 times the quantity x minus 2 squared, he got the red graph, but he was trying to get the blue graph. So you'll notice that all of his roots are correct, and he's got it bouncing off the x-axis at the right place, but something's missing. And so that's the multiplier is what's missing. So let's take a look at how we can find that multiplier. So the first thing you need to do in finding a multiplier is to write your equation with a multiplier. So here's Melvin's equation. I don't know what the multiplier is, so I just put the letter A. Now I can pick a point from the graph, any point on the graph, and plug it into this equation that we have gotten. So Melvin said that 116 was on the graph, so I'm going to put 16 in where the y is, so that gives me 16 equal to, and then a times, and I'm going to put 1 in everywhere there's an x, so I get 1 plus 3 times 1 plus 1 times 1 minus 2 quantity squared. And so when you do the math, you end up with 16 equals 8 times a, so therefore our multiplier must be 2. So now our equation is y equals 2 times the quantity x plus 3 times the quantity x plus 1 times the quantity x minus 2 squared. So if you were to put that into Desmos, you would see that Melvin's graph now would match up with the blue graph. So here's another graph. Let's just look at writing the equation. So the first step is to find the roots and look for where it bounces. The second is to write the equation using those roots and a multiplier, which we're going to call a until we figure it out, and then we're going to plug in a point to find a. So we can see the roots are -2, 0 and 2, 0. And we also see that the graph bounces off of the x-axis at -2, 0. So that would give us y equals a times the quantity x plus 2 squared times the quantity x minus 2. We're going to square that x plus 2, so that gives us the bounce at -2. But now we've got to solve for a. And if you look at the graph carefully, you'll see that it crosses the y-axis at 0, 16. So we have this point 0, 16 to plug in. So I'm going to put 0 in for x. How nice is that? And 16 in for y. So we end up with 16 is equal to a times, and then 1 plus 2, 0 plus 2 is 2, and 2 squared is 4. And then 0 minus 2 is -2, so I get a times 4 times -2. So a then becomes -4. Our final equation then is y equals -4 times the quantity x plus 2 squared times the quantity x minus 2. So now I think you're ready to try your skills at the Desmos slides 12 through 14. So if you've already done Desmos slides 12 through 14 and written equations that match the graphs, congratulations. And if you have not, if you were not able to get equations that match the graphs, then you can go back to slides 12 through 14 and finish that activity. So hopefully now you can find the equation of any graph by finding the roots and the bounce and the multiplier. Good skill to you, and happy spring break next week.